Fellow geometers and seekers of general truths, we will now discuss how to solve some problems that involve lengths and circles. So we have two questions here. I will do one of them and leave the other one to you. And the information that we're given here is that BC is a radius of circle C and AB is tangent to the circle. So from that bit of information, that AB here is tangent to the circle, it's going to be tangent at this point. That angle there must be 90 degrees. Also, let's add another point here. Let's call that D. Okay. So one other thing that may be useful later is that BC and DC here are in fact congruent to each other. Okay, they're congruent to each other. Okay, so maybe that's useful, maybe it's not. Who knows? Okay, but from this information, we should be able to find the radius of the circle. Okay, so let's get to it. We have a Pythagorean theorem type of problem here. Let's call the radius of the circle here x, and so we end up with x squared plus 96 squared is equal to the hypotenuse squared, or 100 squared. And so this is x squared. 96 squared will give us, I need to use my calculator for this, 9,216. And 100 squared will give us 10,000. So now if we do the subtraction, x squared is equal to 10,000 minus 9,216. So this gives us 784. X is equal to the square root of 784. And I think this is going to turn out to be a nice number for us, which is just exactly 28. Okay. So the radius of the circle here is 28. Notice we didn't really use the fact that these two line segments here, CD and CB, are congruent, but it's good to put it in there anyways. Okay. So let's now look at number 2, and I'll start you off. This line segment and this line segment are congruent. Let's name both of them X. And this time, what you should see here is that we're not given the full length, the hypotenuse. We're just given this partial length. So we have to be very careful in how we set up this question. It's going to be AB squared plus BC squared is equal to AC squared. AB here is 32, so that we can substitute in 32 squared. BC squared here is just x, so that's x squared. And AC here is x plus 16, quantity squared. And I will leave it to you from this point on to answer the question. I will just put a hint here that be very careful how you multiply with this out. This is not x squared plus 16 squared. I repeat, this is not x squared plus 16 squared. So I'll leave it to you to finish that question. Now I am going to move on. Okay, so after finishing the question, you should see that this turns out to be 1,024 plus x squared is equal to, and we can work out all of the details here. This is going to actually be x plus 16 times x plus 16. So this is x squared, and we have to, what we do call distribute or FOIL. X times x is x squared, 16 times x is 16, and then x times 16 is 16, so we get 32x, and then 16 times 16 is 256. Notice here that we could subtract x squared from both sides. And then we will get 1024 is equal to 32x plus 56. Subtract 56 from 1024, and we get 968 is equal to 32x. And then what we want to do lastly is divide by 32, and so 968 divided by 32 gives us 30.25. So the radius here is 30.25, and that is our final answer. So a couple things to take away: be careful how we set up problems, which lengths were given, and secondly, to be very careful how we multiply out the results. Alright, I am going to proceed here with the next example. We want to, K and M here are points of tangent C. Find the value of x. Well, remember, there's a theorem that we can use here, and because the two lines are the points K and M are both points of tangent C, JK and JM must be segments of tangents. So by the theorem that we learned earlier, these two line segments here must be equal to each other. So 3x squared minus 10 must be equal to 17. Add 10 to both sides, and we get 3x squared equals 27. Then we want to divide both sides by 3, and that gives us that x squared is equal to 9. Take the square root of both sides, and we can get that x is equal to 3. And that is our final answer. Alright, now this time I'm actually going to stop solving the problem and leave this to try on your own. So work it out as best you can, and then give your answer when you're done. As always, thank you for watching. Ask for clarification when you need it, and have a wonderful day.